Matrices and arrays are multi-dimensional generalizations of vectors with all the elements of same type. Next is a marks. Again, under marks, we are considering a vector form, that's C of 85, 90. INF or minus INF. It says a positive infinity or a negative infinity. Hello everyone, I welcome you all to the second session of first unit, that's Introduction to R Language. Yeah, this is under the subject Statistical Computing and R Programming. That's our first subject under 5th semester BCA. My name is Deepa Kutnikar. I'm working as an assistant professor under Department of Computer Science, Vidhyaashram, Temple of Excellence, Mysuru. So yes, let's see what are the things we have discussed in the last session. So this is a recap. In the last session, we did discuss like the definition of statistical computing and what the statistical computing is also called as and why it is used. So up next, we also discussed the introduction to R language, like why R, what are the different features of R language, different numeric and arithmetic operators, assignment operators. Also, we did discuss about the vectors as well as the vector arithmetic. So this was discussed in the last session. So I just request you to watch that previous video. Let's see the agenda of today's session. So yes, under this session, we'll be discussing the matrix and the different types, as well as matrix and the arrays, list, the non-numeric values, what are the different data frames, and also we'll be discussing about the different special values in R, what is correction, yeah, and also we will be discussing about the basic plotting techniques, like yes, how to plot basic scatter plot or the line graph and all these things in this today's session. Let's see what is matrix. So yes, matrices, as we know, matrices and arrays are multi-dimensional generalizations of vectors with all the elements of same type. Yes, exactly, that's very important. For the matrix or the arrays, the element should be of same type, okay? So that's very crucial when we speak with respect to matrix or the arrays. So now let's know like what is a matrix with respect to R language. So yes, it will be having few dimension attributes like specifying different rows as well as the columns. So that's with respect to the matrix under the R. Now let's consider an example like how to create a matrix under this R language. So let's consider an example like creating a matrix. So let's create a matrix. So as we know, the assignment operator is a arrow, okay? Now how is it represented? We can see that's matrix of 1:6. So yes, it should be having the elements from 1 to 6, but the number of rows is 2 as well as the columns is 3. So yes, it will be something like this. The number of rows will be 2 and the number of columns will be 3. So yes, this is a representation as well as the creation of a matrix under R. Up next, the row-wise filling pattern. So yes, the syntax for that is like matrix of 1:6, and over here there will be no column specified because no need of that. We have to just fill our rows. So yes, that's n row equals 2. Yes, we should have 2 rows and by row equals 2. So yes, this is how we'll be representing the row-wise filling. Clear? So over here we have to, we are specifying like whatever we have informed here, it's true. And please go ahead with the allocation. Great, right? So next, let's see accessing elements. So in order to accept the different elements inside the matrix, what is the pattern or the format, or also we can say what's the syntax for that. So yes, over here, now let's consider an example of a 3x3 matrix so that it will be helpful for us to 3x3 matrix like 1, 2, 3, 4, 5, 6, 7, 8, 9. So yes, this is a 3x3 matrix, and now let's access the elements according to this example. Correct, right? Over here we have a first example like we need m of 1, 2, that's the first row and the column second element. So yes, let's see which is that element over here in this example. The row 1. Yes, absolutely. This is my row 1. and column 2 element. So which is the column 2? This one, correct? The element is 4. The second example over here is M of 3. So yes, what it says, like we need the entire third column. So yes, over here we can observe the first entry specifies the row, the second entry specifies the column. So let's see, the entire third column is required over here. So what's the entire third column? So it's none other than our 7, 8, 9. So let's write the 7, 8 as well as the 9. So up next, the next example is M of 2 comma empty space, which specifies like the entire row. Which row? Second row. Okay. So yes, it is requesting the access of entire second row. So yes, the entire second row values are, what are those? Yes, it's none other than 2, 5, 8. 2, 5 as well as 8. So this is how we'll be going to access the elements inside our matrix using the R language. Clear, right? Now let's understand what is an array. Arrays can be multidimensional. So yes, we can observe here array can have more than 2 dimensions. Arrays is also nothing but multidimensional generalization of the matrices. Okay. So yes, multidimensional generalization of matrix. Up next, how to create an array. Let's see that. Yes, creating an array. So let's consider an representation how the array creation goes. The syntax for that is A is been assigned with a array value where it says the value will be from 1 is to 8 with a dimension. Why dimension is provided? Because it's an array. It is multidimensional. So it has provided with a multidimensional array of the vectors. That's 2, 2, 2. Great, right? So this is a creation of an array. So up next, let's see what are the uses of this. Yes, exactly. It's ideal for 2D as well as the 3D data. Along with that, we can access it with multiple indices. So let's see what's next. Yes, absolutely. It's non-numeric values. So yes, non-numeric values in the sense logical values where we can define it in terms of true or false. And why is it used? Yes, exactly. It is used for the comparisons. So now how to represent that? Like, yes, x is greater than 5. Now, if in case the x is equal to, so now in case, let's consider the value of x be 6. Now, let's see, is 6 greater than 5? Yes, absolutely. Then what should be the logical answer for this? It must be a true, correct? So this is how the logical operations goes. And up next, let's see character or the text strings. So how to define the characters or the text strings? So yes, exactly like we have a name. So what has to be assigned with the name? Yes, the Ravi has to be assigned with the name. Okay. So up next, let's see how to represent a complex number. Yes, absolutely. We know that complex number will be in the form of 2 plus 3i, something like that. Correct? So let's see the example over here. Yes, the complex number can be represented as z with a assignment operator. That's done. What's the value? Complex value. That's 2 plus 3i has to be assigned to the z. Okay. So now with respect to mod z, so yes, mod of z, what does it indicate? Absolutely, it indicates the modulus value. So these are the different functions where we can utilize them according to our requirement. So now let's see what is a list. Yeah. So list, till now we did saw multi-dimensional. Now let's see list, which is a collection of objects of any type. There is nothing like it should be a complete vector or it should be a complete array. No, it's a collection of multiple operations or operands. Yeah. So now let's see how to create a list. So now let's create a list for a student. So yes, a list is been created with a name student. So this is our assignment operator with an open parenthesis. Now, what's the name of the student? So yes, the name will be Asha and the age of the student is 20 and the scores, correct? So what is the C? The C is it specifies like it is a vector assignment. So it is defining a same type of data. So yes, absolutely right. We are just seeing the marks over here. So the marks are same type of a data. So that's why the C over here. Okay. Or if you want, you can just take down. It represents the vector. Okay. Clear? So this is how we can create or represent a list. So let's see next the accessing element. So how to access the element which is inside a list. So for that we can utilize this student $name, and we can also go with the in depth by defining the which particular number. Yeah. So that's by the big braces. So yes, this is how we can access the element from our list. Up next is the data frames. So yes, data frame is nothing but it's a table-like structure and it is ideal for data sets. What we can represent inside it is we can represent columns like vectors of equal length, and also it can contain different data types as per columns. Okay. So now let's see how can we create a data frame. So yes, this is a representation of the syntax like data frame. So we are using df assignment operator. So now it starts data dot frame, open parenthesis. So now we have to represent what is that. So initially we'll be representing a name, that's with respect to this example. So yes, we have considered a C which specifies a vector value, a Tom as well as a Jerry. Yes, both are a name type. And now next is a marks. Again under marks we are considering a vector form, that's C of 85, 90. Great, right? So what is 85? The marks of Tom, and the 90 is a marks of Jerry. So now let's see the past value like whether it is true or false. So yes, in order to represent that, again we are using the vector C and we are defining true, false. So this is how we can create a data frame. Clear? Now let's see how can we access some data from this data frame. Yes, accessing. So now we use df $sign of marks. So what's the value that we have to give? That's from 1, 2. So this is how we can access the data from the data frame. Now let's see what are the different values, or we can say some special values which we utilize in R. Yeah. So let's see that. Yes, absolutely. Over there we can observe the first one, that's NA colon. It specifies like there is some missing data. Okay. So how to represent that? So the representation is X with the assignment operator NA. If this is there, if this is used, means it represents that there is some missing data inside that vector or that data frame. Okay. So now the next one, it's NaN, which says not a number. The next one is INF or minus INF. It says a positive infinity or a negative infinity. So the example for that, either we can consider 1 by 0 or minus value 1 by 0. Okay. So now the next one, null. Absolutely, we know this. Correct. So what does a null specify? That's like there is nothing. Okay. So yes, which says no object. So up next, handling missing value. So this is a format what we can utilize in order to represent it. Up next, let's see the classes. So yes, over here it is nothing but a type of object which we use. So yes, over here we can see class of 3,14. What does it represent? It represents a numeric value, correct? So yes, it's a numeric value. And over here the next one, class of text. So yes, this is nothing but a character value. So now let's see the next topic, that's co-erection. So yes, co-erection, it's nothing but automatic conversion of values from one data type to another during execution of an operation. It is called as co-erection. So now we can say it is completely implicit, like it is done by the program itself. Yeah. So it is done by the system itself whenever it is required. Let's see the mixing types in a vector. So how to represent that mixing types? Yes, it's by in this way, like C, it specifies vector, correct? Inside that we have 1, 2, that's a character, a numeric, a character, as well as a logical value also. So that's a mixing types in a vector. Yeah. So now what we can say, all converted to character. So is it possible? No, right? That's wrong. So what should we get? So we should get a, so we'll be specifying the special value, that's NA, that's invalid correction, right? So now let's see how the correction happens explicitly. So now for that explicit correction, we can provide has dot character, or we can, if you want to define some number, then we can use this has, comma, numeric of open and close parenthesis, and similarly has logical open and close parenthesis. Now let's see what are the examples of this correction. So over here, numeric to character, yes, we can use has dot character. So is it an implicit or explicit? So yes, exactly, this is explicit correction. So now character to numeric, yes, absolutely, we can use has dot numeric of 7. Now logical to numeric, yeah, so how to represent that? By has dot numeric of true, that's when it is true, or we can go for false as has dot numeric of false. So this is few examples of the correction. Let's move forward and see the different basic plotting. So yes, we do know the basic plots, correct? So now let's see and understand what are the basic plots which are considered under R language. Yeah, so the basic R graphics offer simple way to create a variety of plots. As we know, the main advantage of R is it supports the visual representation of data, right? So according to that, over here, we can use this R in order to represent our data in the pictorial form or in a graph format, okay? That's a visualization format. So now let's see it forms a variety of plots. So over here are some common types of plots and their basic usage. So moving on with the first one is a scatter plot. So how the scatter plot will be? So yes, absolutely, it will be in this way. Like we have x-axis, y-axis, we have few data for that, and we'll just pointing the information. So this format is called as a scatter plot. Now let's see what's the syntax in order to create this. Yeah. So over here we can consider scatter plot from, we are defining the values for x, that's from 1 to 10. So over here we have our value from 1 to 10 and the y is defined as a power of the value x. Great, right? So x and y are defined, and now next what we have to define, that's a plot. So yes, this is very, very important. Now within that plot, let's see how to define the scatter plot. So yes, we should have that x and y values, correct, right? So that's a basic requirement. Yes, it's done. Now I have to define what's my plot. So that's will be defined by mean equals scatter plot. Done. So now the x lab value, which specifies the values of x, the y similarly the values of y, and the pitch equals 19. It specifies the design, okay? And now the color, it should be in blue color. So this is a format, yeah, a simple format we can consider like how to represent the scatter plot. Up next, let's see how to add some elements inside the plot. If anything is missed, we need to add it, correct? So now let's see what's the format for that. So over here, the lines and points can be added in this format, like AB line of h equals 50 and the column equals red. Also, for adding a points, we can consider this like 5, 25. What is this 5, 25? Exactly, it's the x and y values, and we are specifying the color of that point as well as the pitch will be 17. It is just saying the representation. Now, if we want to give some text annotations, So for that, we can say text of 5, 30, midpoint, where the annotation has to be happen. So that's at the exact midpoint. So yes, in this way, we can add few elements inside our plots. Now we are done with our scatter plot. Next, let's see the line plot. So yes, over here, yes, absolutely, this is a line plot. Okay, so now this line plot is useful for visualizing trends over time or ordered categories. Yeah, so now let's see how the basic line plot goes. So yes, even for this, we are defining some x and y values in the form of a vector. So yes, representation of x and y, it's done. Now, yes, exactly, the main thing, the plot started. So over there, what is the prerequisite? The x and y, yes, it's done. Now, what's the type? So, yes, we are defining the type, and the main, under main, we have to define a line plot. So, before we did so, for scatter plot, we were just mentioning scatter plot here. And now, as it's a line plot, we have to define that line over here. Similarly, if we want to add some color, we can define the color, and the X label, Y label, we can define. So, this is a format. Okay. Now, the type line. So the type L, it specifies. What does it specify? Yes, exactly. It specifies that the plot should use a line. Okay. So yes, that's a line plot. Up next, let's see histogram plot. Yeah. So yes, histogram plot. Yes, this plot. So you are recalling, right? The basic plots. What was scattered plot, line plot, and now histogram plot. Yes, thus exactly this representation, we call it as a histogram plot. Okay. Now let's see. It displays the distribution of a single numeric variables. So yes, it represents the distribution of a single numeric variable. Now let's see how to define that or how to create. So yes, it starts with a data being assigned with some values like C of 1, 2, 3. So this is a values, and now we have to define that value. So now it starts, that's histogram of data, comma, main. So what's the kind? So the kind of plot has to be entered along with this main command. Okay. So yes, we have mentioned it has a histogram. That's correct. So now for X label, what do we need? It should be defined as a value, and the Y label has a frequency. So what my X label should be? Yes, it's a value, and the Y label must be represented as a frequency. Okay, so over here we are having this color COL as well as a border. What does a color represent? Yes, exactly, it represents the inside color of the histogram block, and the border, it represents this outside border, which color it should be. Yes, this is with respect to histogram plot. Yes, in this unit, these were the few very important points. Like if we know like how to go ahead and define a scatter plot and the line plot as well as the histogram, we can easily go with the bar plot. Correct, right? So up next is just the advancement. If we know these things, this forms a set of basics for our future plots. Okay. So yes, you can plot a graph or visualize the things or the data according to your requirement. Okay. So yes, that's it with this unit. Thank you.